Addressing arc fault circuit interrupter, or AFCI, challenges in older homes, particularly those involving shared neutrals, requires careful consideration and strategic solutions. AFCIs are designed to protect against arc faults, the common cause of electrical fires, but their sensitivity can lead to nuisance tripping in systems with older wiring configurations. When dealing with shared neutrals, where multiple circuits share a single neutral conductor, AFCIs can become unreliable due to the combined return currents. Several approaches can be taken to mitigate these issues. Firstly, consider using a ground fault circuit interrupter, or GFCI, breaker instead of an AFCI breaker. While AFCIs are specifically designed to detect arc faults, GFCIs are designed to detect ground faults, which occur when current leaks to ground. Although GFCIs do not provide the same level of arc fault protection as AFCIs, they can be more reliable in systems with shared neutrals because they are less sensitive to the fluctuations caused by multiple circuits sharing a neutral. Secondly, installing an AFCI subpanel can isolate AFCI-protected circuits. Creating a separate subpanel dedicated solely to the bedroom or other area requiring AFCI protection can minimize interference from other circuits in the home. This subpanel should have its own dedicated neutral and ground bus bars, ensuring that the AFCI circuits are isolated from the shared neutral issues present in the main panel. This approach can significantly reduce the likelihood of nuisance tripping and improve the overall reliability of the AFCI protection. Thirdly, utilizing a piggyback AFCI breaker can be another solution, but this is dependent on panel space and existing circuit configurations. If the electrical panel has sufficient space, an AFCI breaker can be installed on a non-neutral circuit, and a piggyback connection can be used to connect it to the shared neutral circuit. This isolates the AFCI breaker from ground faults on other circuits that share the neutral, reducing the potential for nuisance tripping. However, this method requires careful wiring and a thorough understanding of the electrical system to ensure proper functionality and safety. Fourthly, contacting a qualified electrician is always advisable, especially when encountering difficulties or uncertainties. A professional electrician can assess the specific wiring conditions of the home, identify potential issues, and recommend the most appropriate solutions. They can also ensure that all electrical work is performed safely and in compliance with local codes and regulations. It is important to be aware of certain comments and considerations regarding AFCIs in older homes. AFCIs are not always compatible with older wiring systems, which may lack the proper grounding and bonding necessary for their optimal performance. Shared neutrals are a common problem in older homes and can cause nuisance tripping of AFCIs due to the combined return currents from multiple circuits. Installing AFCIs in older homes can be challenging due to limited space in electrical panels and difficulty accessing or identifying the neutral conductors. Also, GFCI breakers provide different protection from AFCIs and may not be sufficient in all cases where arc fault protection is required. AFCI subpanels can add significant cost to the installation due to the additional materials and labor involved. There are some common gripes associated with AFCIs, particularly in older homes. AFCIs are often perceived as overly sensitive, tripping on legitimate loads such as power tools or refrigerators due to the electrical noise they generate. Shared neutrals are a prevalent issue in older homes, making AFCI installation difficult and prone to nuisance tripping. AFCIs can be expensive, both in terms of the cost of the devices themselves and the labor required for installation, especially when modifications to the existing wiring are necessary. There are additional tips to consider when working with AFCIs in older homes. Testing the neutral continuity before installing AFCIs can help identify potential problems with shared neutrals or loose connections. Use a selective AFCI that only trips on the affected circuit rather than tripping multiple circuits simultaneously to minimize disruption. Consider upgrading the wiring to provide a separate neutral conductor for each circuit, which is the ideal solution for eliminating shared neutral issues and ensuring proper AFCI functionality. If all other measures fail, it may be necessary to abandon the AFCI installation altogether and rely on alternative protection methods such as smoke alarms and carbon monoxide detectors to ensure safety. The decision to use AFCIs in older homes with shared neutrals should be based on a careful assessment of the specific wiring conditions, the potential for nuisance tripping, and the overall safety goals. While AFCIs provide valuable protection against arc faults, they are not always the best solution in every situation. Consulting with a qualified electrician is essential to determine the most appropriate course of action and ensure that all electrical work is performed safely and in compliance with applicable codes. It's important to understand that AFCIs work by detecting abnormal electrical activity that could indicate an arc fault. Arc faults are dangerous because they can generate intense heat, leading to fires. However, AFCIs can sometimes misinterpret normal electrical noise as an arc fault, causing them to trip unnecessarily. This is more likely to happen in older homes with outdated wiring and shared neutrals. When dealing with shared neutrals, the return current for multiple circuits flows through a single neutral conductor. This can create electrical imbalances and fluctuations that AFCIs may interpret as arc faults. In such cases, the AFCI breaker may trip even when there is no actual arc fault present. One of the most effective ways to address this issue is to separate the neutral conductors for each circuit. This involves running a dedicated neutral wire from each circuit back to the electrical panel, ensuring that the return current from each circuit flows independently. While this can be a time-consuming and expensive undertaking, it is the most reliable way to eliminate shared neutral issues and ensure proper AFCI functionality. Another approach is to use a combination of AFCI and GFCI protection. GFCI breakers are designed to detect ground faults, which occur when current leaks to ground. While GFCI protection is not a substitute for AFCI protection, it can provide an additional layer of safety and reduce the likelihood of nuisance tripping in systems with shared neutrals. In some cases, it may be possible to use a dual-function AFCI and GFCI breaker, which combines both types of protection in a single device. These breakers are designed to detect both arc faults and ground faults, providing comprehensive protection against electrical hazards. However, it is important to ensure that the dual-function breaker is compatible with the existing wiring and meets all applicable code requirements. When installing AFCIs in older homes, it is also important to pay attention to the quality of the wiring and connections. Loose or corroded connections can create electrical noise and contribute to nuisance tripping. Before installing AFCIs, it is advisable to inspect all wiring and connections, tightening any loose connections and replacing any damaged or corroded wiring. In addition to addressing shared neutral issues and ensuring proper wiring, it is also important to educate homeowners about the purpose and function of AFCIs. Many homeowners are unfamiliar with AFCIs and may not understand why they are tripping. By explaining the benefits of AFCI protection and providing guidance on how to avoid nuisance tripping, electricians can help homeowners appreciate the value of AFCIs and reduce the likelihood of complaints. In some cases, nuisance tripping may be caused by specific appliances or devices that generate excessive electrical noise. Identifying and replacing these devices can help to reduce the frequency of nuisance tripping. Electricians can use specialized testing equipment to identify sources of electrical noise and recommend appropriate solutions. When all other measures have failed, it may be necessary to consider alternative protection methods. Smoke alarms and carbon monoxide detectors are essential safety devices that should be installed in all homes, regardless of whether or not AFCIs are present. These devices can provide early warning of fires and carbon monoxide leaks, allowing occupants to escape safely. In addition to smoke alarms and carbon monoxide detectors, surge protectors can also help to protect against electrical hazards. Surge protectors are designed to protect electronic devices from voltage spikes, which can damage sensitive equipment and cause fires. By installing surge protectors at the electrical panel and at individual outlets, homeowners can reduce the risk of electrical damage and fire. Ultimately, the decision of whether or not to install AFCIs in older homes with shared neutrals is a complex one that should be made on a case-by-case basis. There are no easy answers, and the best course of action will depend on the specific wiring conditions, the homeowner's preferences, and the applicable code requirements. However, by carefully considering all of the factors involved and consulting with a qualified electrician, it is possible to find a solution that provides adequate protection against electrical hazards while minimizing the risk of nuisance tripping. It is also important to stay up to date on the latest developments in AFCI technology. Manufacturers are constantly working to improve the performance and reliability of AFCIs, and new models are being introduced that are less prone to nuisance tripping. By staying informed about these advances, electricians can provide their customers with the best possible protection against electrical hazards. In addition to the technical aspects of AFCI installation, it is also important to consider the legal and ethical implications. Electricians have a responsibility to provide their customers with safe and reliable electrical systems. This includes ensuring that all work is performed in compliance with applicable codes and standards. It also includes advising customers about the risks and benefits of different protection options. Electricians should never pressure customers to install AFCIs if they are not appropriate for their situation. Instead, they should provide customers with all of the information they need to make an informed decision. It is also important to document all work that is performed, including any recommendations that are made to the customer. This documentation can be helpful in the event of a dispute or legal claim. Finally, electricians should always be willing to stand behind their work. If a customer experiences problems with their electrical system after AFCIs have been installed, the electrician should be willing to investigate the problem and make any necessary repairs. By providing excellent customer service, electricians can build trust and reputation, ensuring that they will continue to be successful in the future.